Okay, warm up. Evaluate. You got these two problems here separate. Two main things from the lesson from before. Be careful. Stop doing the things you've done before if you're not doing this correctly, because you're just not being careful with it. That's a subtract sign. Bring that down. You don't see parentheses around that. So it's going to be 5 squared is 25 plus 1. Negative 25, it is a minus, but you can, if you want to, write down plus a negative 25 plus 1. That is negative 24. Okay? The problem is bad habits. Okay, if you have bad habits, then you get these problems wrong. My story goes to parentheses. 1 plus 2 is 3. Division and multiply, whichever one comes first out of division and multiply, that's the one you're going to do first. 6 divided by 2 is 3 times 3 is 9. All right. All right, lesson for today is 1B, transformations of the absolute value function. Pause the video, have everything ready. All right, so how do you graph a absolute value function? What does it look like on a graph? Okay, so the way I teach it is that we want to do a table of values and really figure out what we can plot points, and then maybe you can see what it looks like. I usually use points that are close to the origin. This is called the origin here. And I'm going to go from, like, say, negative 3 all the way to 3 here and figure out what does it look like here. All right? So let's see here. Erase this. All right, here. So I usually go with inputs. These x values are called inputs. So my inputs are going to be from negative 3 all the way to positive 3. All right, so these become inputs, and then you plug it into this, and you're going to get an output y. Okay, so if I plug in x is negative 3, take out the x and plug in negative 3 in here. What is the absolute value of negative 3? Absolute value of negative 3, all it's saying is that how far are you away on the number line from 0? So on the number line, this is 0, x is negative 1 here, negative 2, negative 3. This is home. Basically, it's how far are you from home, where home is 0. So these don't mean much. Don't get confused on it. It's just how many steps, how far are you from here? You're 3. And absolute is just always positive. It's 3 steps or something. Direction doesn't matter, because it's just how far are you from where this is at. So that's kind of just all you need to understand is absolute value of negative 3, which is it's 3. It's positive 3. If you understand what I just said, then how far are you from 0? If you're at negative 2, you're 2 steps away. 1, you're at home. 0. 1, absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of 3 is 3. How do you plot these points? On the graph, the x-axis is the horizontal. This is called the horizontal axis is x. Vertical axis is y. X is negative 3. When an input of negative 3, don't put a dot. When x is negative 3, the y is positive 3. Now you put a dot where they match up. Negative 3, 3. X is negative 2, y is 2. X is negative 1, y is 1. X is 0, y is 0. X is 1, y is 1. X is 2, y is 2. So you pretty much would have a good idea here. It looks like it's going straight like that and then turn around going straight like this. It looks like a V. The absolute value function looks like a V. Okay. Now that we know that the absolute value function looks like a V, this is the parent function. Absolute value y is equal to the absolute value of x. Is this. But what happens when we put a negative in front of the absolute value? Well, let's go ahead and do it. Do a table of values. If I do plug in x is -3 here, and then I do have a minus here, goes back to order of operation. You will have to do this absolute value of -3 first. So absolute value of -3 is +3, and the minus comes down. Key, that's the key to understanding this. So it is going to be, all of them are going to be negatives. So that's going to be a -3. That's going to be a -2, -1. Well, except the 0. 0 is going to be absolute value of 0 is 0. There's no such thing. No such thing as a -0. That's just 0. Okay, let's not do that. Let's even get rid of it. There's no such thing as this. Negative of the absolute value of 1 is -1. -2, -3. Let's plot the points. -3, -3, -2, -2, -1, -1, 0, 0, 1 is -1, 2, -2, 3, -3. There's the graph. Okay. What do you notice about this this other one? What do you notice about this one and putting a negative in front of it? And then it became this one here. It's called reflection about the x-axis. It got reflected. It's got flipped. So whenever you put a negative in front of anything, it flips it with respect to the x-axis. The parent function was reflected about the x-axis. Okay, what happens when you put a 2 in front of the absolute? Now I think we can keep on going faster. The absolute value of -3 is 3. So we have absolute value of -3 with the 2 outside. We still got to work this out, which is going to be +3. Then we got a 2 in the front, 6. And we're just going to keep on doing this. 6, 4, 2, 0, 2, 4, 6. Plot the points. What do you notice? What has happened to this original V to become this red one? It was vertically stretched up by a factor of 2. So basically it got raised up 1, 2 over 1. It got raised up 2. So it's a vertical stretch by a factor of 2. And out of all, this always is the one that makes almost no sense to people. People are like, why does it do that? That's the reason why we're just gonna work it out and figure out why it does that. Let's go ahead and plug it in. And so this x is -3 plus 3. -3 plus 3 is 0. Absolute value of 0 is 0. And we're gonna get all these points like that. 0, 1, 2, 3, 4, 5, 6. And we plot those points. And you say, well, what is this doing? It's a straight line now? No, it's not. This is kind of deceiving. Let's plug in -4. Let's see what's doing here on the left. -4. If I do plug in -4 plus 3, you got to test more points. That's going to be -1. Absolute value of -1 is +1. So now it went up here again. So it does change directions. So now it's like this. So there it is, the V. But you notice that the original function got shifted to the left 3. So it went left 3, which is opposite of what you think it would do, because this is plus 3. So if you're confused, there's really no explanation. You're thinking, why didn't it go to the right? All you need to remember is that it just, when it's in the inside, it does the opposite of what you might think it does. So the parent function gets horizontally shifted 3 units to the left. This one is a more straightforward one. We do a table of values. You do go ahead and plug in x is -3 here. X is -3 makes it +3. And then you have +3 take away 4, that's -1. So now we got -1. You got -2, -3, -4. And you got these numbers, plot the numbers. And there it is. So when it's not inside of the absolute but outside, it will directly do a shift down directly. So this point will be shifted 1, 2, 3, 4 down. Shifted down. So it's going to be shifted down 4. The parent function was vertically shifted down 4. Problem 6. If the graph of the equation y equals absolute value of x is shifted 2 units to the right, 5 units up, what is the equation that describes the new function? So you got this parent function. You got this parent function, y is equal to absolute value of x, and they're saying that if we shift it 2 units to the right, that means a horizontal shift. So if it goes to the right 2, you're going to put a -2 in the inside, because that's the opposite of what you think it will do. So you're going to put a -2. And then 5 units up, that would be directly on the outside plus 5. So then this is going to be, the new function will be y equals x minus 2 plus 5. Because this, again, it got shifted to the right, which is opposite of what you get in the right, you think it does. Let me see, cancel. Here we go. Yep, there it is. So now number 7, if the graph of the equation is this, now this is already a shifted function, and we want to shift this function 3 units left, meaning if it's going to go left 3, it's going to add 3, because it's opposite. And then 2 units up, you're going to directly add 2. So this function is going to be y equals negative absolute value of x plus 5 on the outside. Moving on to this one, we'll do a different video on this one. All right, stop.